For this video, you'll be taking all the information you know how to do now to calculate quartiles and making a box plot to visually represent that 5-number summary. So some vocabulary you need to get down is what is a box plot? A box plot is a graphical display to show the quartiles of a data set. Each point or line shows 25% of the data. So if we look at this example of a box plot, you're always going to have a number line or at least numbers under your box plot so you know what each of the values are. So we can tell that the minimum will always be the first mark, and that's probably at about 17, I'd say. And this first chunk right here is 25% of the data. The next mark, the first line here, is the first quartile. And we see our first quartile can be measured at about 30. And between the first quartile and the median, or the second quartile, that's the next 25% of data. So depending on how tight or large the span is of the whiskers, these are called whiskers, or the part of the box, it shows the concentration of data. So there's 25% has a very small range between the first and second quartile, but the first 25% has a much larger range, hence this longer section. So the shorter the range, the higher the concentration in that part of the data. So that's probably the most common section, whatever this box plot was measuring, sedimentation rate. The highest rate was probably around here, most common rate. And then we have the next 25% of data between our medium and our third quartile, and then the last 25% of data between our third quartile and our maximum. Remember that this here will be our interquartile range between your first quartile and your third quartile. And then you're going to see outliers marked as dots that are outside of the box plot because they are not part of the majority of data, but they're still part of the distribution. They are not included in our box plot, so we mark them with little dots. So how do we draw a box plot? We're going to use the same data that we used yesterday with the 9 cousins at a family reunion. And we know the minimum is 4, the Q1 is 6.5, the Q2 is 10, Q3 is 13.5, and maximum is 15, and these are all years. So the first thing you have to do when making your box plot is to draw a number line. And I see it at least needs to go from 4 to 15, so I'm just going to start at 2, and I'm going to go up by 2. So 4, 6, 8, 10, 12, 14, 16, and you can go by whatever scale you want to fit your data in. And the first thing I'm going to do is mark my minimum at 4 with a line and mark my maximum at 15 with a line. Now my Q1, I'm going to put that in a red line. I draw a line at 6.5, so that's going to be right about there. And I'm going to draw my Q3 with a line. It's going to be at 13.5, so right about there. And then I will draw my median, and I'll do that in green. And my median's at 10, so I'm going to draw another line right about there. And now, all I have to do is draw the box. And then I have to connect the minimum and max with these whiskers. I had no outliers, I remember, from calculating the IQR yesterday. So my box plot is done. I have my min, my max, my Q1, my Q2, and my Q3. So all you do to create a box plot is to draw lines above the 5-number summary that you know how to calculate and connect them with the box, and make sure your min and max are connected to the box with the whiskers. The next important thing you need to know how to do is how to interpret a box plot. So in this problem, freshman students were asked how much time they spend on homework and watching TV every night. So our first box plot here shows homework time. And remember, each of these little pieces show a quarter of the data, or 25%. Each of these are 25%, another 25%. This very long whisker here just shows that this was not very common for students to spend between 60 and 190 minutes on homework. Same thing here, 25%. Okay, so what percent of freshmen watch at least 15 minutes of TV every night? So I see 15 minutes of TV right here, and I know this here is 25% of the data. So 25% of students watched less than 15%. That means that I'm including this entire piece, which I know is 75% of data, because this is 25% and this is 25% and this is 25%. So 75% of freshmen watch at least 15 minutes of TV every night. The next question, is it more common for a freshman to spend an hour watching TV or an hour doing homework? So we need to analyze our dot plots a little bit. Well, I see an hour is 60 minutes, and that's right here on my TV time, and that's right here on my homework time. And I see that only 25% of students spend at least an hour on their homework. We only have 25% left over because this whole chunk here is going to be 75%. But for watching TV, I see that at least 50% of students spend over an hour watching TV instead of doing their homework. So I'm going to say it's more common for freshmen to watch TV based on the data that we see in our box plot, because 50%, oops, that should have been this, 50% of freshmen watch at least an hour of TV, but only 25% of freshmen watch at least an hour, do an hour of homework. So for your hot question, I want you to look back at the box plots in the previous slide on freshmen watching TV and freshmen doing homework. What percent of freshmen spend between 20 minutes and 60 minutes on homework every night? And what is another name for this range of data? Answer that in your hot question, and we will work on this tomorrow.